Hello everyone, welcome back to channels. I am Ram. In today's video we are diving into two very important concepts in machine learnings, overfit and underfittings. These ideas are key to building the models that actually work well on new data, not just the data they train on. So before starting this video, if you are new to the channel, so guys please make sure like, comment and subscribe my channel. So now let's get started. So now let's try to understand what is the overfit and underfit. What is the overfit? Overfitting happens when a machine learning model learns the training data too well, including all the noise, random flexions or errors. Imagine students memorizing every answers to the practice test instead of understanding concept. They might get the perfect mark on the test but fail when faced the new questions. The same things happen with respect to the machine learning. Overfitting model perform extremely well with the training dataset, but it's fail to perform with the testing datasets. That means these models is not the generalized models. If I talk about the overfitting scenario, when the model perform well with the training dataset and it's fail to perform with the testing dataset, that means these models is not generalized models. For the example, if I just talk about the overfittings, see these models. This is an example with respect to the overfitting. See, these models has degree 3 in the polynomials regressions, which fit the training data too well. Low bias model fit every well with the training and thus produce the low errors. High variance for the test data, the model produced the very high error, and thus the difference between training and testing errors is high. You can able to see here the error is much high with respect to training and testing, right? The error is much high. That means this model is perform well with the training dataset and it's failed to perform with the testing dataset. So in this particular scenario we can say the model is overfit. In this particular scenario, what I can say, the model is overfit because see the model perform well with the training dataset and it's failed to perform with the testing dataset. So the technically what we can say, the low bias and high variance. Now let's go and talk about the underfitting. Underfitting happens when the model is too simple to capture the underlying pattern in the data. It's like a student who did not study enough their answer and obtained wrong or incomplete. Underfitted model perform poorly on the both training data and test data because it has not learned enough from the data. So what is the meaning of this one? That means the models fail to perform with the training dataset and also fail to perform with the testing dataset. For the example with respect to this one, you can see here the linear regressions not fit for the non-linear data. High bias, the model could not identify the true nature of the data. Low variance, any data will produce the high error in this model, so all the error will be the high. There will not much difference between the errors. So what I can say, in this particular case, the model failed to perform with the training dataset and also failed to perform with the testing dataset. So the technically in this particular case, what I can say, high bias and high variance. Now visualizing the overfit and underfittings. Imagine the scatter plot of the point representing our data and we are trying to fit the curve to it. Fitted models might be straight lines that does not fit the data points well at all. It missed the pattern. A perfectly fitted the models capture the general trends without the changing the every small bump. And the overfit models try to touch the every point, resulting in the very widely curves and then fit the training data perfectly, but it's too complex. See the real world scenario, what happens? See the overfit often occur when the model are very complex, like deep neural network with the many layers. When you are working with the deep neural network like that, the ANNA, artificial neural network, That times we have multiple neural networks, and with respect to decision tree we have a multiples the leaf node. It's very grow deeply. Underfit might be happen when the model that are too simple, like the linear regression for the highly non-linear data. And then how to detect the overfit and underfit? In order to detect the overfit, the model perform well with the training dataset and it's failed to perform with the testing dataset. That means the model is overfit. This is the scenario is the low bias and high variance. And with respect to the underfit, the model failed to perform with the training dataset and also it's failed to perform with the testing dataset. That means is the high bias and high variance. Alright, and how to fix the overfitting? Simplifying the models. For the example, reducing the layer of the tree depth using the regularization technique. L1 L2 L1 and L2 is nothing, the leads and the lasso, in order to preventing the overfit. Adding the more training data using the dropout layer in the neural network. When you are training the any kind of the deep neural network like the ANN, then you can, in order to preventing the overfit, you can use the dropout layers. Applying the early stopping during the training. The summary. Let me talk about the summary. The overfittings equal to the model learn the noise, bad generalizations. Underfittings, model too simple, poor learning. The goal to find out the balance for the best performance. If I just talk about with respect to the generalized model, you can see this model has a degree 2 in the polynomial regression, which fit the good with the training data but also generalized so that it can be fit with the test data also. Low bias, better models for the learning data that recognize that the true nature of the data. Low variance, both the training and test error is close so that no much difference. So right now what I'm going to do, I have written the some code with respect to the underfittings, the how the model is looking like that if the model is underfit. So this is the simple models where I have trained the one models. I have imported the library which is the NumPy, matplotlibs and the linear regressions, and then the performance matrix. I have taken the mean square errors and then I have randomly generated the some data, and then finally have split the data into the independent and dependent variables, and then finally we taken the underfit models because the degree is 1 which is the linears, and then the degree equal to 1 which is, then I have the fit and then transfer, and then finally I have fit the model with respect to the linear regression. Then we do the predictions and then we apply the performance matrix which is the mean square errors, and then finally we plot this particular model. Let's execute this code. Now let's try to understand what this plot is basically indicating. See this black dot is nothing. This black dot is the noisy observations from the curve. The black dot is nothing. This is the noisy observation from the curve, right? And this, see, our model is a simple learning regressions, right? But the degree is 1 and the polynomials. It shows the red line. The red lines is nothing. This red lines is the polynomials, which is the degree 1. So we can also notice that the red line is almost straight lines. This red line is almost straight lines, but it's failed to capture the curve of the shape. See, it's failed to capture the curve of the shape. So you can see it's failed to capture of the shape. So this is the because of this model is too simple, but it cannot learn the true relationship. We can able to see this. See, this model is the too simple, but it cannot able to learn the true relationship. This model is a completely simple, but see, it cannot able to learn the true relationship. So if I just talk about the training mean square error is a high, indicating is the poor fit, because see the training mean square error is nothing. The output is a 3.42. That means is a quite high, right? That one is nothing. That means is a quite high. So in this particular scenario, what I am going to say, this model is underfit because of why? See, the models, it's failed to perform with the training data set, and also it's failed to perform with the testing data set. So that is all with respect to the underfit, and right now I am just moving to the good model. That means is the generalized model. The example I have taken the same. I have trained the one model using the NumPy library, matplotlib, and then the model is the same linear regression, and then the performance matrix is the mean square errors, and then I have randomly generated the data with help of the NumPy, and then finally I have split the data into independent and dependent variables. And here the main things you have to be understand with respect to the degree. The degree is the nothing, this is the quadratics, is the degree I have taken in this particular case is 2, right? And then with help of this degree 2 I am going to train this model, and the model is the same. I fit this model, and then finally we predict this model, and then we have also the performance matrix is the mean square error is the same, and then we are going to plotting this particular model. So after plotting these models, the output what I am going to get. So now let's try to understand what this plot is basically indicating. See, the true function is nothing, this is a no noise, and then the good fit model is a degree 2. In this particular case I have taken the degree 2, and the previous I have taken the degree 1. That times the models was the underfit. When I taking the degree equal to 1, see the degree equal to 1, that means this model is underfit. And if I just take the degree equal to 2, that means my model is good. Why I am saying this the good models? Because see, we are increasing the model complexity with help of the quadratic polynomial degree, right? See, this green line is nothing, this green line is representing, this is the model predictions. This green line is nothing, this is the model predictions. This is the model prediction. So you can able to see there the how the closely follow the true curve and the noisy data. Yes, we can able to see this. But also you can able to see there the training error is a much lower compared to the underfit. If I just see here, it's so lower, it's not a big difference. But with respect to if I just talk about the underfit models, see the training errors, the huge difference between this curve and this data points, it's a much different. But with respect to the good model, see we cannot tell this model is either overfit and underfit, because see this the training error is a much lower, there is not much difference, it's lower. And if I just talk about this, the mean absolute error is a training 2.53, right? 2.53 is in this the good model. And if I just talk about the underfit is a 3.42. That means definitely this underfit model is a huge difference. And if I just talk about the generalized, which is the best model, there is my training mean absolute error is a 2.53, which is a absolutely good, right? So this means the model learned the underlying pattern well while ignoring the noise. So in this particular case, what I am going to say, this model is a generalized model. It's because of why? Because see the model perform well with the training data set and also with the testing data set. So now let's talk about the overfit. The overfit scenario, I have taken the same example with respect to the good fit and the underfit. Okay, the same example, the library is the same, NumPy, matplotlib, and then the polynomials features, and then the model is nothing, the linear regression, and then the performance matrix is the mean square errors, and then I have just with help of the NumPy I have generated the data, and then we did we split the data into the independent and dependent variables, and then finally we fit the model. But this time I am going to take the degree is equal to 15. It's very complex, super complex. See the degree equal to 15, and then finally we fit the models, and then we predict, and then we are plotting. Let's execute this code. Now let's try to understand what this plot is basically indicating. See, we fit the very complex models of polynomials of the degree using the 50. Now see these blue lines is we get access to pass through the almost every training point. See, every training point it's passing, every training point. See this blue line almost passing every training point. This blue line is passing to the every training point, right? You can able to see this blue line. Here you can see the training mean absolute error is a 1.82, and the degree is 15 and there is a true function is a no noise, it's okay. But you can see this blue line is passing through all the training data set. This blue line is passing through all the training data set. So if this fit to the noise in the data set, not just the true underlying curve. Again I am repeating, it fit the noise in the data, not just the true underlying curve. So this is why the extremely low training error but the poor ability to predict the new data set. See, yes, we have a mean absolute error is lower, 1.82. See, the extremely lower training error, the training error is lower, but with respect to ability to predict the new data set, it's much poor. That the scenario we can say this model is overfit. That means the model perform well with the training data set and it's failed to perform with the testing data set. So you can able to see there the training mean absolute error, which is nothing, 1.83. This is the, it's a very extremely low training error. There is no, see, low training error, but with respect to ability to predict the new data point, it's very poor. So in this particular scenario we can say this model is the overfit. That means the model perform well with the training data set, but it's failed to perform with the testing data set. And then technical word is the low bias and high variance. Guys, that's all for today. So please guys, do not forget to like, subscribe my channel. Thank you so much for watching this video. Bye bye.